Hello, everyone, and thank you very much for tuning into the Cloud Native FM podcast. My name is Saim Savdar, your co-host for this show. And today we're talking about Wasm, and Wasm is gaining a lot of traction in a lot of different cloud native environment. So we want to better understand why keep people and companies are spending time on it. And for the best part, I have the best person who can answer all these questions. His name is Matt Butcher. I already did an episode with him last year. We will talk about container and Wasm synergies between them. But a bit about introduction of Matt Butcher. He's a co-founder and CEO of Fermyon Technologies, and also at the WebAssembly in the cloud company. Basically, Matt is one of the original creator of Helm, my favorite tool, Brigade, CNAB, OAM, and Glide, and Crucelet. I hope I'm pronouncing all these names correctly. He has written and co-written many books, including Learning Helm and Go in Practice. He is a co-creator of Illustrated Children Guide to Kubernetes series. And these days, he works mostly on WebAssembly projects such as Spin, Fermyon Cloud, and Brothel. I'm able to pronounce his name. I will be asking in a minute for Brad. And I learned this. I'm really surprised that I wish I know before. He holds a PhD in philosophy and he lives in Colorado. So over to you, Matt. If I'm missing something, your time to add into it.
Oh, yeah, I'm super excited to be back. I guess it's been just about a year since we last talked. And it was Bartholomew. That's the worst project name I have ever come up with in my life. It's too many syllables. But it is when we first built Fermyon, we wanted to run our own website on WebAssembly. And so Bartholomew was a content system for running websites in WebAssembly.
I spent the whole day today and yesterday and tried to pronounce it correctly, but I fail. I totally fail. So I get it. I just include the link in the screen so people can know what we're
There you
talking
go.
about. But thank you
Yep.
very much. It's been a pleasure talking to you once again. I learned a lot from you last year, I think in September, October time frame.
Yeah.
And once again, it's a very good time to chat about it. Some of the things is the Fermyon technology and the company and the open source and the ecosystem is heading towards too. So let's talk
Mhm.
about SpinKube today. And I can sit the center stage for some of the people here. SpinKube is a framework that generates a lot of buzz for running WebAssembly workload on Kubernetes. Some people think, why we run WebAssembly workload on Kubernetes if we have container? That's a question for the Mac today. But
Mhm.
Fermyon, Microsoft, SUSE, Liquid Reply, and other collectively release open source SpinKube project for running Spin-flavored Wasm Kubernetes application. And SUSE announced a Rancher desktop support for WebAssembly using
Mhm.
its K3s Kubernetes runtime. And also Fermyon Technology, the CEO of the company is right next to me. I'm talking to him today, is announced a commercial support for ultra-dense Fermyon platform for Kubernetes capable of running 5,000 Wasm apps per Kubernetes node. That's a big one. So I want, and also NGINX Unit announced support for running Spin apps inside of its application platform. And CNCF actually announced, I think, Wasm Cloud project release, I think earlier this year in October, on March, April for reach 1.0 support for Kubernetes integration. So Matt, sorry, but I added so much in the plate.
That's
So
a lot.
what,
But it's good. It's why it's so exciting, is that so many things are happening.
yes, absolutely. So first thing first, let people know what is SpinKube, and on top, why we run Wasm workload on Kubernetes.
Mhm. Yeah. And I'll step one step further back and remind people what Spin is. That's what we talked about a year ago with Spin. Spin is a developer tool for building sort of serverless function style applications with WebAssembly. So when we're talking serverless functions, we're talking about, an application that is not running, right, until a request comes in. Then it starts up, handles the request, and shuts down. So Amazon Lambda is an example of that. Cloudflare workers are an example of that. And Spin is an example of that. So Spin's a tool for developing that kind of application. And the sort of cool thing about Spin is that because it uses WebAssembly, you can write in all these different languages and all have them compile down to the same binary format, and that binary format runs just about anywhere. So the idea was, you could build your applications and you can run them on ARM when ARM is cheaper than Intel, or you can run them on Windows or Linux or Mac OS natively, in all of those cases. One of the places that we really wanted to make it possible to run these kinds of applications was inside of Kubernetes. Now, part of that is probably because about 5/6 of Fermyon is Kubernetes engineers, and we have all worked on various things like Helm and Brigade and Kubernetes itself over the years. And of course, it's as we would say, sort of near and dear to our hearts, right? It's something we really care about. So there's that element. But the other element was really that we heard from a lot of people that their organizations had already invested deeply in Kubernetes, that Kubernetes was the way their company did stuff. And so if they could run Spin applications in there, it made all of their management much easier, right? They could deploy all their applications into the same thing. And, one particular story that really struck me is, I was talking to developers of Lambda and asking them, well, what do you use it for? What value do you get out of it? Because I wanted to learn better how we should build Spin. And one engineer said to me, he said, Lambda is sort of like our Frankenstein's monster of a project. Everything else runs in our Kubernetes cluster and it's very nice and very tidy. And then we've got this one sort of, he called it, it was the one ugly thing that didn't match anything else in their network. And they had all these policies to manage just the Lambda. And the developers had a separate deployment path for Lambda functions than for everything else they were working on. And he said, we don't like that. It's hard to manage. It's hard to maintain. It's hard for everybody to learn. It's hard to debug. And so that story kind of solidified for me the need to run serverless functions inside of Kubernetes, but still deliver the same kind of value that people get when they're using Cloudflare workers or when they're using Lambda. And some of those things are, ultra, you want really high performance. Ideally, you want like Cloudflare faster performance, right? You want nearly instant cold start times. You want very high scalability. You want the ability to deploy very quickly. So all of that is background, right? I'm getting into all my favorite features, but all of that is background for saying what we decided to do was write a runtime for Kubernetes. And Microsoft had already been working on this. They had contributed this project called RunWASI to the Containerd project. And essentially RunWASI was this cool little sort of like an interceptor. So when you deploy a container into Kubernetes, you write this big YAML manifest, and one or more of the controllers takes the YAML manifest and picks out what needs to be done and starts to schedule things. And part of that scheduling is it finds the container image and the description of how to run that container, and it sends it to this program called Containerd. And Containerd's only real job is to fetch that container and start it up and make sure it stays running, right? So it's like one simple cog in this giant complex Kubernetes machine, but that's its job. And the engineers at Microsoft said, well, we can package WebAssembly files inside of container images. What if instead of putting them inside of containers, we just pulled out the WebAssembly and executed that? So we could use the exact same Kubernetes descriptions we use for containers. And then when the execution gets all the way down to that Containerd thing, whose job is to start and run the container, it will recognize, oh, this isn't a container, this is a WebAssembly file, and it'll execute a WebAssembly runtime instead. So in that case, right, once you can do that, then you can run a container and a WebAssembly side by side in Kubernetes. So that was kind of the big start for us. But we also needed a bunch of other things to make sure that when you deployed WebAssembly into Kubernetes, then everything got wired up and your volumes mounted correctly and your secrets and your config maps all worked and that your service meshes worked. And so, together with Microsoft, with Liquid Reply, who wrote a bunch of operators, with SUSE, who wrote a bunch of code for this as well, we created SpinKube, which is the whole umbrella of tools you need to run inside of Kubernetes. I think we released that at KubeCon Paris, and I think a new release of it is right about to come out in the next couple of weeks. Probably by the time you're listening to this podcast, the new version of SpinKube will be out.
Awesome, Matt. Thanks for sharing all these wonderful details as well. I think one thing really shines to me is that previously I was scared, like, why if there's a new ecosystem evolves around for the Wasm, like we have a Kubernetes ecosystem, then there's a container ecosystem, and then there is a Wasm ecosystem, and then people think, we love all these technologies, but how do I manage time to learn all these kind of activities, because these all required steep learning curve. And not many people in the ecosystem are nerdy. They want to solve the business problem and go away and enjoy the life with their family and friends. So
yeah.
they're not like us. We will spend all day, all time with the machines and all these kind of stuff. So it's great. Like, I think one thing is another great is the name is quite very catchy. The SpinKube. I wish not a very different name. So it's a great correlation with them. So I think right now, if the people is got quite very excited with all the things we mentioned today, they wanted to learn how the SpinKube does work, because in the container ecosystem, when it came up, we started building images, then pushing them into the Docker Hub, and then deploy them, and then running it in locally, and then we go into the Kubernetes, and the whole ecosystem got to be a change. But in a Wasm, what is the ideal developer workflow today's look like?
Yeah. And you already hit sort of the most important point when, even before asking the question, right? We want to build an ecosystem, or we want to extend the ecosystem maybe, so that it's easy for people to use, right? We don't want people to have to learn, a dozen new tools and a new way of thinking about things before they can build WebAssembly applications and deploy them into Kubernetes. So there are kind of three pieces to talk about to answer the question. One is Spin. The second one is images, OCI images or Docker images. And then the third one is sort of how you deploy it. So I'll talk through each of those very briefly. Creating new WebAssembly applications is what Spin is for. So prior to Spin existing, if you wanted to write a WebAssembly application, you would have to download between 4 and nearly a dozen tools, depending on what language you were going to use and how you were going to build it and how you were going to link it up and run it. And that's too many, right? That's 4 to a dozen new things you have to learn, and we really don't want to have that many. So when we built Spin, we built it using the kind of pattern we had already seen work well in platform as a service, in PaaS, right? So, Spin was designed to have really just 4 commands. Spin created a new project for you, set up all the WebAssembly tool chain for you. Spin build compiled your application into a WebAssembly binary for you. Spin up started it up so you could test it locally, and Spin deploy pushed it out so you could run it remotely. So originally Spin was really just designed with 4 basic commands. We added a couple others like Spin test and Spin doctor, things that would help you during your development cycle. But it's those 4 that are the big ones. So and we talked about this a little bit last year, right? Our core design goal, the number one user story we had when building Spin was, as a developer, I should be able to go from a blinking cursor to a deployed application in 2 minutes or less, right? And I love the way you phrased it, because it's like we want to spend time with our families on the weekend. We want to enjoy life in the evenings. So anything we can do to make the tool easier and faster during our work hours is a big win. And so that was why we made that kind of a core story. So you build, you deploy, and then it's running somewhere, right? So from the developer point of view, that's kind of the way we wanted Spin to work. The second part of that is, we needed a packaging format that we could bundle up the WebAssembly and the supporting files and stuff like that and be able to move it around. As as every engineer does, I think my first shot at it back when I was working on this stuff was to create my own. And then somebody says to me, well, why are you creating your own package format? We already have a whole bunch of them. And so, Radu and the rest of the engineering team at Fermyon started looking at good package formats and went, why do we not just use OCI images? That's a Docker. OCI and Docker images mean the same thing. OCI is the standards body. Docker, of course, is the company that created all of this. But excuse me, an OCI image is sort of a description of one or more binary files that go together. And then a way to push and pull all of those files together. And in the original Docker ecosystem, in fact, this is still true today. The way the OCI image worked is it would store a list of chunks of a file system, each as a tarball. And you would say, hey, I want my NGINX image. And it would grab the image out of the repository and say, I need these 4 chunks of a file system, pull each of those down, and then sort of overlay them, reconstitute them into one file system, and that was your Docker image. It was absolutely brilliant way of doing things. It was one of the coolest pieces of Docker, if you ever have time, is this layered file system that they use. And we looked at it and went, well, what if, we just stored all our WebAssemblies in there, and instead of, turning them back into a file system on the other time, turn them into a WebAssembly executable application on the other side. And so the OCI specification allows for this. There's a sub-specification called the artifact spec that says exactly how you would do this. We just follow the specification. Once more, Microsoft, Docker, SUSE, all the companies you would expect to be interested in this were part of that endeavor to figure out how to do it. Docker Desktop supports WebAssembly, Rancher Desktop supports WebAssembly, Azure AKS supports WebAssembly, and they all do it this same way, right? We just store our stuff in Docker images. So part 1 was figuring out how to write the application with Spin. Part 2 was figuring out how to package and move the application around, which is OCI images. Part 3 is figuring out then how do we make it really simple for a developer or for a platform engineer to install and operate this. Kubernetes provides a really good YAML-based description of how to run an application. And so when we built SpinKube, we said, it should look as close as possible to a container style runtime. So in the end, the same primitive, a pod, is used to describe running a WebAssembly application. In fact, I should pause there and say, the way the whole thing works, you literally can run one pod in Kubernetes with SpinKube that has a container and a WebAssembly both in the image list, and they'll run side by side. So it really does plumb everything all the way down to the very bottom of Kubernetes, and it all just works. Kubernetes is an incredibly elegant system. And because of that, you can swap in and out components in very intriguing, maybe weird ways that maybe people would never have expected. And that's one of them. You can actually run a container and a WebAssembly side by side in the same pod, have them both managed side by side. And that means you can take your long running database and your, serverless function and manage them with one deployment or something like that. But with SpinKube, we also added a couple of other manifest formats called a Spin app is the main one. And that one allows you to describe a Spin application at an even higher level. So a typical Spin app YAML definition is about 12 to 20 lines. So it's very short. So the goal in all of these, right? The developer story, the operations story, the platform engineering story was to keep these all as similar to your existing tool set as possible, so that, again, you opened this so well for me. Again, there are fewer things we have to learn. It all just kind of works with the tools we're used to using and the accounts we're used to having in various places. Various places. And so that's how we did it.
Absolutely. And when I first look at when the announcement made, I think in KubeCon Paris timeframe, and I look at it, and then I see there are incredible engineers in this world who understand Kubernetes perfectly better than me. And they understand what the flow we are using, and they added the same flow in the pipeline, and then they extended the Kubernetes that they can add more functionality besides container just running inside it as well. So it's a very incredible engineering. A thumbs up to all the folks who actually did some wonderful research on this project. But I need to actually did a summary of this, because people think, oh, what the hell is they talking about? So I just give a small summary. So first thing, the SpinKube works on the same Kubernetes cluster where you are. That's why it's a SpinKube. But now you're running your Wasm application. So Wasm workload packaging, as Matt talked about, the Wasm workload is a package similar to the container, but instead of using the OCI compliant image, it uses a Wasm module. So it is by design. And next, now we want to deploy this workload into the Kubernetes. Then the SpinKube framework schedule and manages these Wasm module across the Kubernetes node, and it can run these modules either on standalone workloads or in a combination of containerized services. And if you look at the SpinKube architecture, it's added new CRDs in the Kubernetes. One is called Spin App, and one is called Spin Operator. So Matt, can you tell us what these CRDs currently doing before I create a complete summary?
Yep. Yeah. And the operator way of doing things, the CRD and operator way of doing things in Kubernetes is what makes Kubernetes so powerful. So when you define a CRD, the way to think about it is just that I am defining a new YAML file form, a new YAML set of descriptions for a new thing. And so if you define a new thing, you can put it in Kubernetes, and Kubernetes says, cool, a new thing. I'm good with that. But it doesn't do anything with it. So you want an operator, and an operator sits there and listens for that thing and says, oh, whenever one of these things gets put in the cluster or modified or deleted or whatever, I'm going to take some actions. And so the spin operator is the one that sits there and watches for a new spin app to be deployed, and then says, I know what to do with this thing. I'm going to turn this into a deployment. I'm going to turn this into a pod definition. I'm going to create a secret over here. And then it pushes those objects back into Kubernetes, and Kubernetes kind of runs through those and handles each of those in turn. And this is a really good, actually, if you want 1 second to say how Kubernetes works, right? This is the way Kubernetes has worked since very early on. When you deploy it, when you push a deployment out, the operator for deployments takes that deployment and says, okay, well, in order to make this work, I need a replication controller. So here's my replication controller. It's going to have this many replicas. So it pushes out the replication controller item. And then that thing, says, all right, well, I need to push out 3 items here, one for, 3 different pods, each one of which is going to run a copy of this application. And it creates 3 pods. And so you get this sort of, iterative tree-like effect where one thing is creating another thing is creating other things. And then when you go and look in Kubernetes, you run your deployment, you can go list your deployments, you'll see one. You can go list your replication controllers, you'll see a replica sets, and you'll see another. You can go list your pods, you'll see 3 more. And so we just kind of followed that same pattern. Spin app is an even higher level abstraction. When you deploy that, it figures out how to run the WebAssembly application, and then it creates the new objects for that. So that's what a spin app does, and that's what the spin operator does, is it manages that process of taking the spin app definition and then creating new objects.
Yes, so these are the same old primitives. You doesn't invent any new wheel in it. It's just a Kubernetes. The way it's supposed to work is how it's worked for a very long time. You're just using the existing you're adding the newer functionality by using the same primitive people have already been using it. And that's the CRD thing is one of the best thing I think Kubernetes give you, because you can extend based on the environment you are operating on, and then the Kubernetes do this heavy lifting for you. So once again, I do a summary of it. You do a Wasm workload. It's a package similar to container, but instead of using the OCI compliant image, and it uses Wasm workload, Wasm module. And now you have a spin framework schedule and manage the Wasm module across the Kubernetes node. And now you look at the architecture. It had spin apps and spin operator. Spin operator basically schedule and look at and monitoring the Wasm module as well. Now the best thing with the SpinKube framework is integrates with Kubernetes monitoring tools such as Prometheus to observe and scale Wasm workload in real time. And this ensures that Wasm applications are scaled automatically, similar to the containerized workload. And also it has a hybrid orchestration. The framework orchestrates both Wasm and container-based workload allowing them to communicate and share resources efficiently. And that's, I'm thinking, why it's by default, because might be some workload I still want to run in a container because Wasm is not a still fit for it. But I want to make sure they need to communicate with each other because they are dependent on each other, irrespective of which language or which framework you are using. So that is by default, by design. So before we actually leave off the conversation here, I want to spend time more on the company's paradigm as well, where you are working on and how the use cases are actually emerged. So give us a quick overview of Fermyon technologies today. And some of the, I know you have actually wrote a Fermyon platform for Kubernetes. And even in beginning of the conversation, you said there's 5,000 Wasm workload you can run on the node inside the Fermyon platform. Can you briefly explain what are the customers for that platform, and what is the scenario is today with Fermyon platform?
Yeah, so we talked already about how containerd is running down at the bottom of this stack, and you can push the definition all the way down, and then it fetches it and says, oh, I have, this is a WebAssembly, I can run that. Containerd works well if you're running a couple hundred apps per node, a couple hundred WebAssembly apps per node. But we wanted to be able to handle this case where you needed, for one reason or another, handle two cases. Either the case where you needed to run a whole lot of applications, right? Serverless platforms often will run thousands or tens of thousands of applications because each one is just a function, right? Or the other case is when you want to be able to scale up nearly instantly from 0 to 5, 10, 15, 100,000, 200,000 instances of something right away. And so that required sort of building out a separate runtime that was very specialized for running these kinds of workloads. Our internal name for it, I don't think we have an external name for it. Our internal name for it is Cyclotron. And this is just a runtime that runs huge numbers of WebAssembly applications. So you can think of it as like one mega process, just this huge process that has the ability to run thousands of WebAssembly sandboxes, so instances of but all of those WebAssembly applications are running inside of the same giant process. And then you can deploy one of these giant processes out to each node in your Kubernetes cluster. And suddenly, I mean, at one point we were doing a test where we were pulling 700,000 WebAssembly instances per second, just like huge numbers of WebAssembly applications. Obviously, most of us don't need to be able to do that all of the time, or some of us, I don't, maybe never, right? But if you're a large organization and you either deal with a lot of traffic or you deal with a lot of applications that you need to run, or both, that's a very attractive option. And so part of the way we do open source at Fermyon is it's a big deal to us to make it easy and possible for anybody to use the technology. But when it comes to something hyper specialized like that, it makes sense to say, well, this is a good place to sell a product, right? For those large enterprises that need this kind of throughput, then we can offer a product like that does that, but not run the risk of, alienating the average developer or the regular sized company who are not going to need that. SpinKube's going to get them 100% of where they need to go. So Fermyon Platform is really designed, that version of it is really designed for large installations. And it has been exciting to see what people are doing there, particularly as AI takes off and serverless functions with AI are really powerful, or, higher density media companies where they might publish an article that suddenly goes viral and they need to be able to scale up really fast. Those kinds of use cases. Zeiss, I think, wrote an article today, or Kai Walter from Zeiss. This is a German company that makes lenses, like for telescopes and reading glasses and microchip manufacturing. And they have cases where a sudden influx of new orders means they need to process 50,000 or 60,000 items as fast as they possibly can. But the rest of the time, that same pipeline might be totally empty. So in order to reduce waste, in order to keep compute running that doesn't need to be running, they can run something like cyclotron and be able to plow through all these requests very quickly and then free up all those resources to go do something else. So that's how Fermyon has decided, that's our big enterprise offering. And the way that we decided we could build a product that was a sellable product at the same time as being an open source company that can still get everybody going on WebAssembly as fast as possible and running it in production on their own terms.
Absolutely, Matt. And I think like right now, if we talk about auto scale up and scale down, we have number of options like we have AWS Lambda, serverless function, now container come into the market. But the efficiency that Wasm brings in, we never have been thought of, we never have seen before. Because in a containerized application, you need to set an heartbeat. Oh, my application is running inside the container carefully. How much resources and CPU comes up. And remember, when your application comes off online from just a matter of a second, that's where it actually becomes in a sleeper mode. You need to set up some primitives, how your application should come out online. And that's required a lot of plumbing code. And I literally don't want it because I haven't seen any developer want to add these functionalities. And this is a very cumbersome. And also in the serverless function, we need to add these kind of functionality. With Wasm, I think this is really shining. You goes off online, and it's just an instance. It's just an instance. It's a so fast application. But remember, it's still required its own learning curve, own paradigms, own new ways of you learning SpinKube and these kind of stuff. And that's where the Fermyon technologies comes up, where you have all the plumbing available. It's just your software developers and the operators and the platform engineering start consuming Wasm-based services. And you just go offline, enjoy your time with friends and family. Never have to think about again application is deploy. That's a problem in our ecosystem, especially in the Kubernetes, because we all are nerdy and we think everybody's nerdy and everybody's not nerdy. They want to just put stuff up there. But Matt, we have to leave today, but I really enjoyed the conversation. What we could do is, viewers who are listening to us, we do a follow-up episode on part 2, where I invite one more guest alongside Matt, and his name is Shivai, who can talk about what is he facing currently, some of the issues his organization are facing, and how the Wasm is solving some of the problem on their own need as well. And hopefully in the near future, I can set up some panel talk with Fermyon and his new friends and colleagues to talk about some of the new aspect of the Wasm could flourishes in well. So Matt, can you wrap up the episode, because you were the best one to wrap up all the things, because we spoke about so many things, unfortunately, on just 3 minutes. So can you wrap up all the things we discussed today?
Yeah, and I think the easiest wrap up is to say, what excited us about WebAssembly when we very first started doing this was that it seemed like there's a possibility to have a new wave of cloud computing, right? That would work alongside our containers, alongside our VMs. And we're a couple of years in now. All of us are a couple of years in and discovering how powerful WebAssembly is. We started by focusing on building developer tools, and we started the show today by talking about Spin and developing WebAssembly applications. But now we're at that point where we're starting to deploy these applications into existing infrastructure. And the exciting thing about Kubernetes, having been involved from the early days, is that I have watched it grow from a small project that kind of worked to this amazing project that is used by 70% of organizations, and that is just incredibly flexible and powerful. It has been so cool to build SpinKube and just integrate a brand new feature set of a brand new technology into this existing one, and have everything just work and make it really easy for developers and platform engineers to get started. Spin, the developer tool, SpinKube, the runtime. I think we're making good progress toward building a really amazing ecosystem.
Yes, absolutely, and totally agree with you. And I think like I definitely see there's a no reason why it's not getting upstream. There's a, as you mentioned, there's a no reason why to adopt container, and there's a no reason why not to adopt the WASM as well. Specifically for the business use cases where the latency is a big issue for them. They want to
Mhm.
spin up efficiently, just a blink of an eye, blink of an cursor, and just to go offline in a minutes, and then reducing the resource efficiency cost associated with it. So I don't see as a reason, and I see the match will be very busy in the next few years. Really in the KubeCon to addressing some of the business use cases for that. But I can try to recap because we spent a lot of time in the SpinKube framework. SpinKube for me is paving the new way for future where WebAssembly workload can be easily managed and orchestrated alongside container on Kubernetes by reducing the overhead associated with traditional container and optimizing resource usage. SpinKube makes it possible to deploy highly efficient workload with minimum latency. And with that, once again, thank you very much. I really enjoy the talk. It's sometime I don't want to end the talk every time I talk with you, but it's so generic and we want to keep talking a full day. But we will be recapping another part two episode, and hopefully you'd enjoy a lot. And we look forward to see what the community response so far for the WASM, because that is really we want to see where the community heading towards too. But Matt, it's pleasure talking to you. I really enjoy the full conversation. And every time we connect, is this new wave of learning comes to my way. You feed me Wasm all the time. So I make a new shirt that's called Feed Me Wasm Matt. So thank you very much. So hope you enjoyed the conversation too. So we will look forward to the part two. Have a wonderful day, everyone, and stay caffeinated.